Lesson 39, using the distributive property to simplify rational expressions. First off, what's a rational expression? It's just an expression with variable in the denominator. And remember, the denominator cannot equal 0. If it does equal 0, then it's undefined because we can never divide by 0. Let's take a look at an example here. We want to distribute over addition. So when we distribute with a fraction or rational expressions, you multiply numerator with numerator and denominator with denominators. So here, x squared times x squared is x to the fourth. And then we have, before we do that one, let's do the denominator. So it'd be y squared times y cubed, or y would be y cubed. So our first term is done. Plus x squared times 3y cubed would be 3x squared y cubed, divided by y squared times m, which is y squared m. And so that would be our answer for that first one there. But we have to figure out what the variables cannot equal. So the variables we look in the denominator our y cannot equal 0, and our m cannot equal 0. Because if they do equal 0, then we would have, we wouldn't be able to solve it because they would be undefined. So you got to make sure you put those, what those variables cannot equal. Next one, a times a squared is a cubed. B squared times b is b cubed, plus we got a times 3b squared is 3ab squared, divided by b squared times z, which would be b squared z. And b and z cannot equal 0 because they're both in the denominator. Next one, r squared times r squared. We got r to the fourth. Denominator q times q cubed is q to the fourth. R squared times 7q cubed is 7r squared q cubed over q times w, which would be qw. And then our variables q and w cannot equal 0. Next one, now this one is over subtraction. So here, do everything the same thing. So we got m times axp divided by z times mk, so zmk, minus, we got, over here we got 2m to the fifth, p to the fourth, divided by, here we got, this is really over 1, so it's times z. And then we have to continue simplifying. We should always check to see if there's any common factors in the numerator and the denominator. And in the first term there is. I can divide an m out in the numerator and the denominator. So those factor each other out. So I'm left with an answer of axp over zk minus 2m to the fifth p to the fourth over z, and then the variables. I have to look at the variables in the whole problem. I have a z, I had an m at the beginning, right over here, that's in the denominator. I have a k. They all cannot equal 0. You have to make sure you look both in your answer and then in the original problem to determine which variables cannot equal 0. Next one here, x times dmy is x squared dmy over c times x squared a, which is c squared x squared a, minus x squared times 2x cubed y would be 2x to the fifth y over over c squared over times 1 is just c squared. And I can simplify the x squareds, cancel each other out. Nothing else. So right now I have an answer of dmy over c squared a minus 2x to the 5th y over c squared. And then our variables in the denominator, c, x, a, all cannot equal 0. Next one, p times uay is tuay over z times tq, z tq minus, remember this is over 1, so t times negative 2t to the 4th y squared over z. I'd like to see if there's anything that we can cancel or simplify. T's divide each other out, so I'm left with uay over zq minus 2t to the 4th y squared over z. And then I look at my variables in the denominator, z, q, t, and those are all, it cannot equal 0. Next one with negative exponents, okay? So here, still distributing, so we got 2b to the 5th over d cubed, d to the negative 3 times d, so a negative 3 plus 1 would be d to the negative 2nd. Put our minus sign down, b cubed times f to the negative 3rd. We got d all over d to the negative 3rd over b. And now here's where we need to simplify here. Remember, we can't have negative exponents, so d to the negative 2nd, to make it d squared, we'd have to move it to the top. So this would be 2b to the 5th d squared all over 1, so we're not going to put that over 1, minus, I can simplify here, I have 1b here, that means I can take 1b away there, so I have b squared. The f to the negative 3rd, to make it positive, it has to go to the denominator, so f cubed is on the denominator. And then I have 1 minus a negative 3, which would be 1 plus 3, so this would be d to the 4th. So that's what our simplified answer would be. And then we look at our denominators. D, B, and F all cannot equal 0. Next one, distribute here. So we got n to the negative 1st. We got mx denominator. We got an m. We got c. We got n to the negative 3rd. We got p to the negative 5th. Plus, we have a 5 n to the negative 1st times n to the negative 4th. We add those two together, it gives you n to the negative 5th. And then we got p to the negative 5th all over m. And let's simplify. I have a negative n to the negative 1st divided by n to the negative 3. So it's n negative 1 minus a negative 3, which is n to the 2nd, positive 2. The m's cancel out here. We're left with an x in the numerator. And then we also need to get rid of our p to the negative 5th in the denominator. So that has to be in the numerator, so p to the 5th. All we're left with in the denominator is c. plus, we have a 5 in the numerator in the second term. The n's have to go to the bottom, so it'd be n to the 5th. P needs to go to the bottom, p to the 5th. And then we're left with m in the denominator. And then we look at the variables. M is in the denominator, C is in the denominator, N is in the denominator, and P is in the denominator. All of those cannot equal 0. That would be our answer for that one. Next one. Here we got j to the negative 5th over m, so 1 plus the negative 2 is m to the negative 1st, plus we got 9 j to the negative 2nds m cubed divided by mk. So we simplify. The j has to go to the denominator, but the m's got to go in the numerator, so I have m over j to the 5th plus, I have the 9 up here. We got m cubed divided by m. So 1m here, subtract 1 there, so we got m squared. And then the j squared's got to go on the bottom to make it positive, and k is already on the bottom. And then we look at our variables. M is in the denominator, k is in the denominator, and j is in the denominator. All of those cannot equal 0. Some more examples here. We got n to the negative 2nds, v to the negative 2nds, cb, all over z and v to the negative 1st. Next term, so minus, we have 4 negative 2nds times n to the 5th, be n to the 3rd. And then we have b to the negative 3rd, all over 1z. So simplify here. This is n to the negative 2nd divided by n. These subtract the 2, so that'd be n to the negative 3rd. So n to the negative 3rd has to be on the bottom, so n cubed. V to the negative 2nd minus a negative 1, be v to the 1st, negative 1, so that has to be on the bottom. C stays on top, b stays on top, and z stays on the bottom. Minus, we have 4 in the numerator, n cubed, b cubed has to go to the denominator, and then we have z. Then our variables in the denominator, n, v, z, and b all cannot equal 0. I need some more. This would be x to the 4th over y. Negative 3 plus 1 is negative 2 minus x squared times 3. So you got 3. X squared is z to the negative 2nd y over y to the negative 3rd x. Let's simplify here. We have x to the 4th y squared, that has to be in the numerator now, minus 3, this x, and 1x away from the numerator, so it's just 1x. We got 1y minus a negative 3y, so that's y to the 4th. That's all over. The z squared has to be on, negative 2nd has to be on the bottom, so z squared is on the bottom. And our variables, we got y, we got z, and we have x, all in denominator. They cannot equal 0. Next one, some more practice with this. We got 3 a to the negative 1st dm over b squared d a to the negative seconds c to the negative fourth plus we have a negative 1 plus a negative 3 is negative 4 c to the negative 4 over b squared. We can simplify here. We have 3 in the numerator. A to the negative first minus a negative 2 is just a. We have a b1 divided by b squared, which would be b to the negative first. So we're going to put b down in the denominator. We have a d in the denominator. We have c to the negative fourth, has to be in the numerator, so c to the fourth. And then we have an m in the numerator. All this plus a's got to go in the denominator, so a to the fourth. C's got to go in the denominator, so c to the fourth. B has to stay there. That leaves us with 1 in the numerator. And our variables a, b, c, d all cannot equal 0. And distributed over multiple operations. So doing the same thing here. So we got a squared, b squared x over c cubed plus 2 ab squared x over c squared, and then minus 4ab over c to the fourth. And I check to see if there's anything in common with the numerator and denominator. There is not. So that part is our answer. And c is the only variable in the denominator. C cannot equal 0. Next one. So here we got g squared times g to the negative second. So if we're adding them, it'd be g to the 0 power. So g to anything to the 0 power is just 1. So that makes it 1. We have h times h is h squared. Then you have an x all over 2 times d to the negative first. So add them, it just gives you d minus, this would be 2 g squared h to the fifth x to the negative first all over d squared plus 9g squared h over 2 plus a negative 3 is d to the negative first. So let's simplify this. That would give us h squared x over d minus 2 g squared h to the fifth over d squared x on the denominator plus 9g squared h d all over 1. And then our variables d and x cannot equal 0. And some more work. So we have f squared s squared h over d to the fifth plus 2 fs squared k over d to the fourth minus 7fs over d to the 10th. And we can simplify that, check to see if there's anything in common. There's nothing in common in the numerator and denominator, and d is the only a variable that we have in the denominator, so d cannot equal 0. Next one, we have z squared x squared d to the negative seconds over w to the negative first plus 5 tz squared x over w to the negative second. Now we have minus 2zx over w negative 2 plus a negative 4 is negative 6. So rewrite that. We got z squared, x squared. And d has to go to the denominator, so d squared. W has to go to the numerator. Plus, we got 5t z squared x w squared has to be in the numerator, minus 2zx w to the sixth has to be in the numerator. The only variable in the denominator is w. W cannot equal 0. So that would be our simplified answer. And another problem. Here we go. We have f squared g cubed x over h squared plus 4 fg squared over h cubed minus 2g cubed xf over h. Nothing's in common with the numerator and denominator. H is only in the denominator. H cannot equal 0. And some more. We got like a couple more problems to go through. So we have m to the negative first, n to the negative third, and r all over. P's will cancel out, so this is just over 1, because negative 2 plus 2 is 0. Then we have m, n to the, n's will cancel out. And we have r to the negative seconds, all over p to the negative seconds, minus 8m squared, n to the negative fourth, over the p to the negative first. So to simplify this, this would be m on the denominator, n cubed in the denominator, r in the numerator, minus m p squared over r squared, minus 8 m squared p over n to the fourth. Their variables m, n, r, and p all cannot equal 0. Next one, application. A tabletop that is in the shape of a trapezoid has a height of a squared c over 2b, and the base is b cubed over c and dA over c squared. The area of the tabletop represents the expression below. Simplify it. So more simplifying these rational expressions. So we have a squared b cubed c over 2bc plus a cubed cd over 2bc squared. And we check to see if there's anything we can simplify, and there are. C's cancel out. I can take a b away. That leaves me with a squared b squared over 2 plus a cubed c, we have a c1 divided by c squared, so that's going to be c to the negative first, so c has to go in the denominator. We have b in the denominator, we have d in the numerator. I can't combine those. At the numerator, the b, the c cannot equal 0. The next application problem. The area of the triangular section of the building has an area represented by the expression below. Simplify this. So this would give us r cubed fq over 2 f to the negative seconds t minus 6 r to the fourth f t cubed q over 2 r to the negative first f to the sixth. Simplify this. We have r cubed f divided by f to the negative seconds is f cubed. And then we have a q all over 2t minus 6 divided by 2 is 3, so I have a 3 here. R to the fourth divided by r to the negative first is r to the fifth. F1 divided by f to the sixth would be f to the negative fifth, so that's in the denominator f to the fifth. And I got t cubed, and I have q. So this would be our answer, and then t, f, and r cannot equal 0. And the last one, do the same thing, simplify. We have t to the negative first, y over 2y to the negative seconds, plus t squared y z to the negative fourth over 2y to the fifth t. We can simplify here. T has to go in the denominator. Y minus a negative 2 is y cubed, so y cubed is in the numerator, plus the t's, one t can cancel out, so I'm just left with t in the numerator. Y1 minus 5 gives you y to the fifth, or y to the negative fourth. So y to the negative fourth has to stay in the bottom. And then z to the negative fourth, z to the fourth in the denominator. And this would be our answer. And then we have y, t, and z cannot equal 0. So this was a longer lesson going through more examples of simplifying rational expressions.